Hello everybody, welcome back to Mathlete's Corner. Last week we did combinations and permutations level 1, and this week we're going to bump it up a little bit to level 2. So we're continuing with some more AIME problems. So let's get right into it. Our first problem is the 2019 AIME 1 problem 4, and it reads, a soccer team has 22 available players. A fixed set of 11 players start the game, the other 11 are substitutes. During the game, the coach can make as many as 3 substitutions, so up to 3 substitutions, where any one of the 11 players in the game is replaced by one of the substitutes. No player removed from the game may re-enter the game, although a substitute entering the game may be replaced later. No two substitutions can happen at the same time. The players involved and the order of the substitutions matter. Let n be the number of ways the coach can make substitutions during the game. Find the remainder when n is divided by 1000. So that was a mouthful. Now, let's look at the condition that seems most interesting to us. And in this question, I would say that that condition is that the coach can make as many as 3 substitutions. That gives us the most natural approach of doing casework on the number of substitutions that the coach makes. So let's do just that. So our first case would be that the coach makes 0 substitutions. So create a column saying number of substitutions and then number of ways. So if our number of substitutions is 0, then there's only one way for the substitutions to play out. Now, if our number of substitutions is 1, then there are 11 ways to choose which player you're taking out of the game, and 11 ways to choose which player you're putting back into the game. So that's 11 times 11, or 11 squared. Now, if we make 2 substitutions, well, there's 11 squared ways to make our first substitution, and then for our second substitution, there are 11 ways to choose who to take out of the game, but now there are only 10 ways to choose who to put into the game. So that comes out to 11 cubed times 10. Now finally, for 3 substitutions, there's 11 cubed times 10 ways to make the first 2 substitutions. And then for our third substitution, there's 11 ways to choose who we take out of the game, but now only 9 ways to choose who to put into the game. So that comes out to 11 to the 4th times 90. Now we know that our value of n is just 1 plus 11 squared plus 11 cubed times 10, 11 to the 4th times 90. Now, a little trick here for finding the remainder when you divide n by 1000 is in these last two terms factoring out our 11 cubed, because the other factor comes out to 10 plus 11 times 90, which is just 1000. So all of this cancels in modulo 1000, and all we're left with is 1 plus 11 squared, which is 122. And that's our final answer for this problem. Now our next problem is the 2015 AIME 2 problem 5. And this one is far shorter than our previous problem. It reads 2 unit squares are selected at random without replacement from an n by n grid of unit squares. Find the least positive integer n such that the probability that the 2 selected unit squares are horizontally or vertically adjacent is less than 1 over 2015. We're dealing with a probability here. So we have to make sure we're counting the successful number of ways to choose 2 squares and the total number of ways to choose 2 squares. Now, in this case, the total is far easier to find because we have n squared total unit squares and we want to choose 2 of them. So that's just n squared, choose 2. Now, for our numerator, we have 2n ways to choose which row or column we're going to be looking at, and we have n minus 1 pairs of adjacent squares. Now it just comes down to simplifying this and making sure it's less than 1 over 2015. So when we do that, this left side comes out to 2n times n minus 1 over n squared times n squared minus 1 all over 2, but the 2 will go into the numerator. This evaluates to 4 times n minus 1 over n squared times n squared minus 1. Now we can use some nice factorizations. We can cancel this n here. We can cancel this n minus 1 with this to leave n plus 1. And now it just comes out to 4 over n times n plus 1 is less than 1 over 2015. Now, cross-multiplying, or getting rid of the fractions, gives 8060 is less than n times n plus 1. What we notice here is that our right side is somewhat close, a little bit larger than n squared. And our left side is almost 8100. So that tells us that n is going to be somewhere close to the square root of 8100, which is equal to 90. So we can test some values. We find out that when n is 89, we see 89 times 90 is equal to 8010, which is actually less than 8060. But when n is exactly 90, we get 90 times 91 is equal to 8190, which is actually greater than 8060. So this gives us our final answer of 90. That's all for this video. Thank you for watching. Don't forget to hit that like and subscribe button, and we'll see you next week here at Mathlete's Corner.